Guys, welcome back. In this video we will learn about circles and we'll see the definition of arc, sector, segment and chord of a circle, and then we'll see some general properties. Then we'll move on to tangents and finally we'll have a look at the ellipse. So let's get started with circle. So what is a circle? So circle has many definitions. To keep it simple, I will call it a round figure without edges. So until now we have seen about polygons, so which we're having some edges or sides, right? A circle will not have any side, so it has zero side, no sides, and it is round. So how round it is? So if we can call this also a circle, this also is round and it has no sides, right? This is almost looking like a oval shape. So what exactly is a circle then? So it is collection of points on a plane that are equidistant from a point. So what it means? So this point is nothing but we'll take some point O and collection of points that are equidistant. So the distance from this point to any other point should be equal. So that distance is called as radius of the circle, and let's represent it by r. So I'll draw a distance any point r. Like that I can keep on drawing, right, like this way on both sides, and I'll get a round figure. Right, I'll get a round figure and this is the circle. Okay, so the distance from any point on the circle to this fixed point is called as the radius and it is given by r. So next is the diameter. Diameter is nothing but 2 times the radius. So it is the largest line segment connecting any 2 points on the circle, right? So if you take any 2 points on the circle, you can see this is some distance d1. If you take these 2 points, it is some distance d2. So like this, if you keep on, the largest distance we can get is the diameter itself, which is given by d. D is equal to 2r. Like for polygons we have perimeter. For circle we define the circumference. So circumference is nothing but, draw a circle, this length, the outer boundary. So it's nothing but the outer boundary, length of the outer boundary. So circumference formula is 2 into pi into radius. So it's 2 pi r, and 2 and r you can combine and write it as pi into diameter. Okay, next we have the area. So area is nothing but pi r square. So pi into square of the radius. So in terms of diameter, if you have to write, it is pi d by 2 whole square. So which is pi d square by 4. So next we'll define something called as an arc. So you have a circle, and if you take any particular segment, if you only consider this circumference, part of a circumference, it is called as an arc. Again you can see with 2 points you can get 2 arcs, right? So one is small and one is big. So the smaller one is called as minor arc and the major one is called as the bigger one is called as the major arc. So if you from the center, if you just join and this makes an angle theta, the entire angle 360 degree will make a circumference, right, which is 2 pi r. For theta we want to find the arc length, so this is arc length. So again we can use the ratios here, right? 360 degree by theta is equal to 2 pi r by arc length. So arc length will be theta by 360 into 2 pi r. So this is this minor arc length. If you want major arc, you need to replace theta with 360 minus theta. In that case, the theta itself will actually be this one. So anyway, it will be applicable for both minor arc and major arc. So next we will see about sector. Sector of a circle. Okay, what do you mean by sector? So you have a circle, you have the center. Suppose you take 2 points. You can see like it is like dividing as pie, right? You have apple pie or something. If you have seen, you might have known. Or even round pizza, right? If you cut it this way, so this part, this entire part is called as minor sector, and this one is major sector. So what is sector? It is part of circle between two radii. This is a sector. So how will you get the area of the sector? Again, this is theta. So for 360 degree, the area is pi r square, correct? So for theta, what will be the area? So question mark will be theta by 360 degree into pi r square. So it will be applicable for major arc itself, in which case theta will be this one, right? But again, so arc length also we know theta by 360 into 2 pi r. So this we can write it as arc length into r by 2, right? So it is half into arc length into r. So this is the arc length and this is the r. It is like saying half into this radius into this arc length. Okay. So next we'll see about segment. So segment is derived from sector. So we have sector. Let's see ABO. If we remove this triangle, right, whatever is remaining is the segment. So this will be the minor segment, and this entire thing this entire portion will be the major segment. Okay. So if this is theta, we already saw the area of triangle AOB is nothing but so it is we already saw that if it is half into the sum of the product of the sides and sine of angle between them. So here it is r into sine theta, so which is half r square sine theta. And the segment area, or a sector area, sector AOB area is, we already saw it, right? Theta by 360 degree into pi r square. So segment area is sector minus the triangle, right? Theta by 360 degree into pi r square minus half r square sine theta. This you can simplify by taking r square common out. and you will get the formula. So this is called as the segment. So next we should also define chord, right? Chord is nothing but line segment connecting any 2 points. So any 2 points you take on the circle AB, you connect these. So AB is a chord. Line segment connecting any 2 points on the circle. So if you see this definition and this definition, so we can say the chord divides the circle into two, minor and major segment. Correct? So we can also define segment using chord. Okay. So next, and also diameter is the largest segment, longest segment. Of the circle. Okay. So then we'll see some general properties. So first property, if you have a circle, center O and some chord AB, and if you draw a perpendicular from the center point O to this chord AB, it will bisect the chord AB. So perpendicular drawn from center to the chord, to any chord, bisects the chord. So what we have, if we join these 2 points, right, these are nothing but the radius, so they are equal, and this one side is common and this one angle is 90 degree. So this triangle is congruent to this triangle. So triangle AOD is congruent to triangle BOD. So then this angle is equal to this angle will be equal to this angle, correct? And this side also anyway equal to this side because of the property. Okay, second property. So the second property follows from the first property. So if you have two chords AB and CD, if you take the perpendicular bisector of these two, they will meet at the center of the circle. So the perpendicular bisectors of two chords, again any two chords of a circle, meet at its center. And third property is, so we need to introduce something called as collinear points. So collinear points means three or more points lie on a straight line. For example, let's say point A, B and C. If I join A and B, if it passes through C, then A, B, C are collinear. Another example, D, E and F. If I join D, E and if does not pass through F, then it is called as non-collinear points. Correct. So now, if there are three or more collinear points, so they all lie on a single line, so we cannot draw a circle passing through all of them. right? Suppose we have 3 or more non-collinear points, then there exist one and only circle, only one circle passing through 3 or more non-collinear points. For example, if I take 3 points, I can always draw a circle passing through this. Like, this is not exact, but see, one construction you can do is, so all these points lie on a circle, so these will become like chord of the circle. Then you take the perpendicular bisector for both, you will find the center. Now you know the radius, this will be the radius, and with this you can draw a circle. It will pass through all of the points. So this is one construction where you can visualize that if there are 3 non-collinear points, there can be one circle drawn through them, and the theorem says that there can be only one and only one circle. So you can't draw 2 or more circles. Okay, fourth point. If you have 2 circles, intersecting at 2 points, this is called as the common chord. Let the centers be O and O dash. So if you draw a line through the connecting the centers, then it will be the perpendicular bisector of this common chord. Okay, because like if you draw from here to here and here to here, it should both bisect this common chord, right? So it's same as saying O if we connect O and O dash. So if 2 circles intersect in 2 points, then the line through the centers is perpendicular bisector of the common chord. Okay, next property is equal chords of a circle are equidistant from its center. So if you have 2 equal chords, then their distance from center should be equal. D1 should be equal to D2. That is what it says. And again, it is easy to prove via congruency. Like, both will be right angle triangle. So this is equal, right? So they should also subtend equal angles, right? This is equal, and the right angle, and this is equal, we have to prove, and this is the radius, right? So with this, using RHS theorem, we can prove that these both are equal, hence this side should be equal to this side, which nothing but they are equidistant from its center. Okay, so next point is converse of this. Equidistant chords from the center are equal in length. This is again easy to prove via congruency. So next theorem is very important and it may be useful in many places. More often we'll find use for it. So if I take any point AB and let's say on the circle this AB subtends an angle of theta, then the angle subtended at the center will be 2 theta. So I'll write down the theorem. The angle subtended by the chord at the center is twice the angle subtended by the same chord at the circle. So this is the circle, here it's subtend theta, then at the center it will subtend 2 theta, and you can see it's the same chord. So if you, what it also means is if you draw any number, however you draw, you just move this point here to here, then you will get something like this, right? So it says this angle remains same theta. That is the beauty of this theorem. Okay. So next also follows from this. Okay. So here we saw it is theta and 2 theta. What happens if you bring these closer and closer? You can see this angle 2 theta approaches 180 degree, right? If you bring this closer and closer, and once it approaches 180 degree, what happens to this? This is theta, right? So theta will tend to 90 degree. So when it approaches 180 degree, when it becomes 180 degree, this is nothing but the diameter itself, right? So AB is diameter. It is the longest chord, and the angle subtended by the diameter is 90 degree. Anywhere you take, it will be 90 degree, any angle. So angle subtended by the diameter of the circle on the circle is 90 degree. This is also very useful and we'll be using it frequently. So next property, we have equal chords of a circle subtend equal angles at the center. If it's subtend equal angle at the center, it also means it is the same at the circle as well, right? So this also can be follows from this derivation. We are just saying this angle is equal to this. Okay. So next, which we already saw, is the cyclic quadrilateral. So if you take a circle and connect any 4 points on the circle, so A, B, C, D, then A, B, C, D is a cyclic quadrilateral. It only means that all the 4 vertices are on the circle. Okay, one special property of this is sum of opposite angles is equal to 180 degree. For a quadrilateral, sum of all angles is all interior angles is is equal to 1a, 360 degree, sorry, 360 degree. But for a cyclic quadrilateral, we get a more special property of angle A plus angle C is equal to 180 degree, and angle B plus angle D is 180 degree. So this is not valid for a normal quadrilateral. This is only valid for a cyclic quadrilateral. Okay. So this much properties are enough mostly to solve most of the questions. How much ever difficult it may be, we can still use these properties to solve them. So next we will see about tangents. So tangent is nothing but if you have a circle and if you have a line, so the line can be interacting with the circle in three ways. The first way is it does not pass through the circle. Pass through or touch the circle. So second is it passes through the circle. So when it passes through the circle, it intersects at 2 points, right? And intersects at 2 points. So what is the third kind? So third kind is the line just grazes over. It just touches the circle at one point. Just touches the circle at one point. So this kind of lines are called as tangents. Tangents or tangent to a circle. So if we have a circle and an exterior point, we can draw two tangents to the circle from this point. So this is almost like one tangent and this is another tangent. So from any exterior point to the circle, we can draw two tangents. From interior point, we can't draw any tangent, right? So interior point, no tangent. And on the circle, is present on the circle, then we can draw only one tangent at that point itself. Okay. So we'll see the properties of this tangent. So if we just connect these 2 points, so this is nothing but the radius, right? So this is equal to this, and what we also have is this is equal to this. So first property is the two tangents drawn from the exterior point are equal. Second property is the radius is perpendicular to the tangent. The radius is perpendicular to the tangent. So it is perpendicular to any tangents. Any tangents you draw, it will be okay. So this is with the properties of tangents. Next we have finally the ellipse. So ellipse is nothing but an oval shape. And it has no edges. It is similar to circle, only that it is elongated on one of its sides than the other. See, if you see this side and this side, you can see this side is smaller than this side. So like we defined radius for a circle, here also we define two quantities, A and B. So A is called as the semi-major axis and B is called as the semi-minor axis. And the perimeter of an ellipse is given by pi into A plus B. So for a circle, A is equal to B is equal to R, right? Then we'll get as 2 pi R. Similarly, can you guess the area of a ellipse? Yes, it is pi into A into B. So in that case, it will become pi R square for a circle. Okay. That's all guys for today. Please go back and revise these concepts so that you can remember them, and also you try to practice a lot so that you can remember them in the long term. Thank you.